All right, here's an example of how to do an Atwood machine when there's a massive pulley, okay? Right, and you can see why it's going to be that, when it says something like the pulley's a uniform disc, and it gives you the mass and radius of the pulley, okay? So that means you're going to have to include that, whereas before we assumed it was a massless pulley and you didn't bother with it, okay? All right. All right, so this one we'll call mass left, mass right. Actually, I don't want to write it right there. Well, yeah, I will. Mass left, mass right. Okay, and you can see that this one's heavier, so you know it's going to go around this way. All right, and basically what you're doing now is you're trying to still draw the force diagrams for the left-right mass and the right mass. Okay, but now you also have to have a force diagram for the pulley. Okay, because the pulley is going to be important now. All right. Okay, so if we know this way, I'll call this MLG, or mass times gravity. Okay, and then upward, this is going to have some kind of a tension. Okay, we'll call that FTL. All right, because it's on the left one. And you know that's going to be smaller than the MLG because that is going to be accelerating. Okay, same thing over here. You're going to have your MRG, and you're going to have a tension that has to be bigger than that so that it can accelerate. And we're going to call that FTR. All right, so the whole point of this now, when there's a massive pulley, these tensions are no longer equal like they were before, okay? Because they're going to have different forces acting on this pulley in order to spin it, right? So if both tensions were equal on the pulley, it wouldn't spin, okay? So the problem now is that I'm going to have FTL. Those are still the same, right? Because they're still attached with the same rope, okay? And then I'm going to have also an FTR, and those are the same. I know they don't look the same, okay, because that's the same rope, all right? Okay, so, but now these two tensions are unequal because the pulley is going to be spinning. So I'm going to call this way positive, right, because that's kind of the way that it's going, all right? And then here, right, down is kind of my positive, here up is my positive, right, because the whole entire system is going around to the left, okay? All right, so now what you're going to have to do is you're going to have multiple equations, all right? So you're going to have the sum of the forces in the y direction equals 0. This is for the left mass. So you're going to have M2G minus FTL equals MLA. Sorry, it's not a 2, it's an L. MLA, okay? And then for the right mass, you're going to have the same thing. Oh, it doesn't equal 0. What am I doing? Oh my God, MA, okay? And then you're gonna have FTR minus MRG equals MRA. MRA, okay? And then you're also gonna have a sum of the torques for the pulley, right? Sum of the torques equals I alpha, okay? So the torque pulling that around in a positive direction is gonna be FTL times the radius, minus FTR times the radius, right, equals I alpha, okay? And since it's a disk, that's a 1/2 mr squared alpha, okay? So now you have these three equations to use, all right? And you should have basically three unknowns, okay? You don't know the tensions, both of them, and you don't know the acceleration, okay? But if you see here, we also have this alpha, all right? So that kind of technically gives us 4 unknowns, but we can't have 4 because we only have 3 equations. So you need another equation, which is going to be that, okay? And that's always going to happen. That's how you're relating the linear or the angular acceleration of the pulley to the linear acceleration of the rope coming off of the pulley. Okay, so that's your 4th equation basically, so that you can have 4 equations and 4 unknowns. All right, and then it's just a matter of solving them, which is sort of a hassle. I'm probably going to run out of space. Oh, maybe not. Okay, so let's see how we can do it. So we know that the acceleration of those masses has to be the same because they're all kind of on the same rope, right? So they're going to have to all move together. All right, so let me think what's the best way to solve this. I think maybe I'm going to put everything in this pulley equation. All right, so let's see if we can solve out. So the FT left is going to be MLG minus MLA, right? If I move that over. And the FTR is going to be MRA plus MRG, okay? Right, if I just kind of revamp those two, all right? And then I'm probably just going to throw everything into this big, huge equation. Is this the best way? I don't know. We're going to see. Okay, so I'm going to have this equation to start with. So FTL radius minus FTR radius equals 1/2 mr squared alpha. Okay, so that's kind of where I'm starting. Now I'm just going to plug all this stuff in. Okay, all right, so the FT2 is going to be MLG minus MLA radius minus MRA plus MRG radius, okay, equals 1/2 mr squared, right? And then my alpha, A over R, right? I want to replace this with A over R, okay? Because then that's going to get rid of my alpha. Okay, so now I think acceleration is my only unknown, right? Everything else is a known quantity, all right? So mathematically, to clean this a little bit, okay, see if I cancel out that R, now every term has an R, so then I can just basically cancel out all the R's. Okay, that's going to clean it up just a little bit, okay? And then I guess I might as well just go ahead and plug the numbers in at this point, and then I'll switch the A's around because I don't feel like dealing with, well, MLG minus MLA minus MRA minus MRG equals 1/2 MA. Okay, remember that capital M is the mass of the pulley. Okay. All right. And then, yeah, I think I'm just going to go ahead and put the numbers now, and then I'll just combine all the A's. Okay, so MLG is 20.7. I'm just going to use 10. So 207, what's that going to be? Newtons, right? Minus ML 20.7A minus 15.1A minus 151 equals 1/2 M is the pulley is 5.33. That's pretty huge. A. Okay. All right, and then let me just kind of clean this up a little bit. 207 minus 151. I hope this is right. I don't think there's an answer, but we're going to hope for the best. Okay, minus 20.7 and 20.7, 15.1. So this is going to be minus 35.8A equals 2.67A. Okay, and I'm just going to add the A to the other side. So 2.67 plus 35.8, 38.47A. So 56 divided by that. Well, that seems like a reasonable number, so I bet it's fine. 1.46 meters per second squared. Okay? I don't even know what they're asking for in this problem. What are they even asking for? Oh, the acceleration. Good. Okay? All right. And then the tension in the left and right sides of the rope. Okay? I trust that you can do that. You're basically just plugging in the numbers for that. Okay? And then you get the tensions. All right? Okay, so that's generally how you're going to solve this, right? You're going to have one equation for one of the masses, one for the other mass. You're going to have a torque equation around the pulley, and then you're always going to need this one, okay? And then that should solve it out. It's just mathematically ugly sometimes, okay?